All right, today we are pulling back the curtain on the apps you use every single day. We're going to break down how they get made from that very first line of code all the way to the updates you get years later. Let's dive in.
You ever just open an app and think, how in the world did this get made? Well, I can tell you it's not magic and it's almost never just a single eureka moment. It's actually a super methodical process, a lot like building a house, brick by brick.
And that whole journey kicks off right here with the most fundamental step of them all, the actual act of coding. This is where the ideas really start to take shape.
So what is coding really? Well, at its heart, it's the language we use to give instructions to computers. Developers take a design, a set of ideas, and they translate it into a language the machine can actually understand and run. It's the craft of building something real out of pure logic.
So let's stick with that house analogy for a bit. If the software is the house, then coding is the physical act of laying down every single brick. Each line of code is one of those bricks, and when you put thousands or even millions of them together, you get the final structure.
But here's the catch. Not all bricks are created equal. You wouldn't build a house with a bunch of cracked, messy bricks, right? Same goes for software. You can't build something great with sloppy, disorganized code. Following best practices, like the ones you see here, is what makes sure that foundation is strong, stable, and isn't going to fall apart later.
Okay, so we're laying the bricks. But imagine if every builder on a construction site just started laying bricks wherever they wanted. You wouldn't get a house, you'd get a total mess. That's why you need a plan. And in software, that plan, that blueprint, is the documentation.
This is literally the blueprint for our software house. Software documentation covers everything, from the big, high-level plans for the whole structure down to tiny notes explaining what one specific piece of code does. It becomes the one single source of truth for the entire project.
And believe me, the difference this makes is just night and day. With a good blueprint, a new developer can jump into a project and get up to speed. When something inevitably breaks, they have a map to figure out the problem. But without it, total chaos. It's like trying to fix a leaky pipe in a house without having any idea where the pipes are even located.
So the bricks are being laid, and they're following the blueprint. But who's checking the actual work? I mean, you'd never build a house without an inspector coming by to make sure the foundation is solid and the wiring is up to code. Well, in software, that inspector is another developer. This whole process is called a code review. Before any new code gets officially added to the project, another developer, a teammate, gives it a thorough look. And they're not just hunting for typos. They're checking for quality, for potential security risks, and just making sure it meets the team's standards. It's a team effort, all about making the final product better.
So, why should you, as the user, even care about this? Because this step is what keeps your apps from breaking down. A tiny little bug that gets caught right here could be the thing that prevents your entire banking app from crashing right when you're trying to log in. Simply put, code review stops problems long before they ever get to you.
All right, the code has been written, it's been reviewed, and now it's time to see if our house can actually handle the real world. We've got to put it through a whole series of intense stress tests to make sure it's safe, reliable, and ready for people to actually move in. Now, testing isn't just one single thing. It's a process with layers. First, you test each individual brick. Then, you make sure the plumbing and the wiring are all working together correctly. And finally, you test the entire house to see if it could survive, say, an earthquake. Let's break down each of those layers.
First up, we have unit testing. This is where developers are checking every single brick, one by one. They'll test a tiny, isolated piece of code, like a function that calculates a percentage, all by itself, just to make sure it does its one specific job perfectly.
Next up is integration testing. Okay, so the percentage function works, and the login function works, but what happens when a user logs in and then tries to use the percentage function? This is where we test how all those different parts talk to each other, making sure the plumbing connects to the electrical system without any leaks or sparks.
And finally, we have system testing. This is the big one. Here, the entire app is tested from start to finish, exactly how a real person would use it. Can you open it, log in, do what you need to do, and log out without a single glitch? This is where we simulate that earthquake to see if the whole structure holds up. So, the house is built, it's been tested, people have moved in, the job is done, right? Ha! Not even close. In the world of software, the launch is just the beginning of what is often the longest and most expensive phase of all, maintenance.
Software maintenance is basically everything that happens after the app is in your hands. It's fixing bugs that slip through testing, it's updating the app so it works on the latest operating system, and it's adding all those cool new features that users are asking for. It's the ongoing renovations and repairs that keep the house livable.
Okay, now get ready for what might be the most surprising fact of this whole process. You'd probably think most of the money goes into building the app in the first place, right? In reality, for most software, a jaw-dropping 60 to 70% of its total lifetime cost is spent after it launches. Not on the initial build, but on maintenance, on keeping it running and making it better over the years.
And maintenance isn't just one thing either. It usually breaks down into 4 key types. You got corrective, which is fixing bugs, adaptive, which is making sure the app works when a new phone or OS comes out, perfective is adding those cool new features, and preventive is about cleaning up old code to prevent problems down the road.
So let's just quickly recap that entire journey. It all starts with coding, laying the bricks. Then we create the blueprint with documentation. A code review acts as the inspection, and a whole suite of tests puts the structure through its paces. And finally, maintenance covers that lifetime of repairs and renovations that keeps the whole thing standing strong.
From a single line of code to a lifetime of updates, it's this incredibly complex, continuous cycle. So the next time you tap open an app, just think about all that hidden architecture, the bricks, the blueprint, the stress tests, and all the constant renovations that make it possible.